This lesson is going over the basics of slope. Now, whenever you hear slope, or sometimes phrased as the rate of change, it's basically just saying how steep is that line. Now, there are 4 different types of slope. I think it's easiest working left to right. So going left to right here, our line is going down left to right. So we call this a negative slope. Looking at our green line, from left to right, it's going up. So this is called a positive slope. From left to right, this is going straight across. So a horizontal line, think about it. How steep is that line? Well, it's not steep at all. Going from here to here, it's not going any up or down. So if it doesn't go any up or down, it's called a zero slope or a no slope. Last but not least, a line that goes straight up and down, or a vertical line, is called undefined. And we'll get into that in a little more detail in a few slides here. Now, when calculating slope, most important formula that you have to remember is rise over run. Now, rise over run, once you have 2 points on a line, you can find the slope. By doing this, you go rise, which means you count up or down first, and then the run, you go side to side. So, a couple helpful hints to remember this. Our rise, think about it. When we go up or down on a graph, you're dealing with your y-axis. So when you think about rise, you are dealing with your y's. The rise is your y's. You're dealing with the y-axis. And think about it. When you run on a surface, you're running straight across. When you think about the axis that goes straight across, that's your x-axis. So when you run, you go straight across. You can't run straight up and down, not even Spider-Man. So, determining which points to use, this is imperative. You have to choose a point that directly goes through an intersection. So, this point would not work because that goes through the middle of those 2 boxes. This point, however, would work because that is an exact intersection between those 2 lines. This one, no, no, no. Last one, this would work because it's an intersection of this line and that line. Once you chose your 2 points, rise over run. I think it's easiest drawing a right triangle straight up and then across to help me count my rise over run. So from this point to this point, we go up 1, 2. So if you go up 2, that's a positive 2. Now think about it, rise over run. Over represents a fraction bar. So 2 over 1, 2, 3. Our run is 3, so we have a slope of 2 over 3 or just 2/3. Meaning every time we go up 2, right 3, there's going to be a point on this line. Look at it here, nothing changes even if it's a negative slope. We know it's negative because it's going down to the right. So pick 2 points. I'll choose this point. There's my intersection and another intersection right there. Draw your triangle, down that many, running that many across. Now how far down do we go? 1, 2, 3. Now if you go down 3, that's represented by the integer -3. Now rise over is my fraction bar, -3 over. How far across do we go? 1, 2, 3 to the right. 3 to the right represents a +3. Now when dealing with this, you gotta look. A negative over a positive is just like saying a negative divided by a positive. You know that a negative divided by a positive is a negative. That's where our negative slope comes in. But also, can this be simplified? Well, yes. A 3 goes into both -3 and 3. So if you divide the numerator and the denominator by 3, we get -1 over 1. Meaning every time we go down 1, right 1, there should be a point. Well, let's check it out. Down 1, right 1. Is that a point? Yes, that's a perfect intersection. Again, down 1, right 1, there's a point. Down 1, right 1 is another point. Simplified, anything over 1 is going to be just the numerator. When you divide anything by 1, the answer is just itself. So our slope here would just be a -1 slope. All right, moving on. Calculating the slope of this line. Now, it doesn't matter which points you choose as long as it's a perfect intersection. I'll show you what I mean. You're going to get the same answer regardless. So if I choose this point and this point, draw my line, we go down 1, 2, 3. So if I go down 3, again, that's a slope of -3, and then over 1. And a slope down 3 over 1, or -3 over 1, is just a slope of -3. Now, if you were to choose this point and that point, those both work. Those are both perfect intersections. You just got to do a little more counting. You count all the way down here, and then across that many. And if you were to do it, you would be counting down 9, which is a -9 over 1, 2, 3. A -9 over 3, meaning that every time we go down 9, right 3, there will be a point. However, this can be simplified. You divide these both by 3, and we get negative 3 over 1, just like we got over here the first time, which simplifies to a slope, again, of negative 3. Now, when we compare slopes, if it's ever asking for which slope is greater or which one has a greater rate of change, look at it. Which line is steeper? Well, let's do it mathematically first. There's a point on A and another point on A. If you draw your triangle, we go up 1 over 4, meaning this slope is 1/4. Looking at B, doesn't matter which 2 points you choose, there's a point, there's a point. My rise is 1, 2, 3, 4 over 1. So my slope is 4 over 1. Like I said, anything over 1, the slope is just going to be the numerator, so slope is 4. Now when you look at these two lines, looking back, which one is steeper? And you would tell me that line B is definitely a lot steeper. So when it says what's the greater rate of change, you would say that line B is steeper, the greater rate of change. Now whenever you have a whole number greater than 1, that's usually going to be a pretty steep line. Now the bigger this number gets, the steeper the line's going to get. Whenever you have a fraction that's less than 1, it's going to be flatter. Because every time we go up 1, we go right 4. Up 1, right 4. Whereas this one goes up 4, right 1, up 4, right 1. Meaning that B is definitely going to be a steeper line. Now, on your own, take the time to pause the video and practice these two on your own real quick. And I'll go over it once you unpause the video. Alright, looking at our green line first. Pick 2 points. I see a point right there and a point right there. Let's do a rise over run. I go up 1, 2, so my rise is 2 over my run will be 1, 2, 3. So that slope would be 2/3, meaning every time I go up 2, right 3, there should be a point. Let's check it. From this point, up 2, right 3, there's another point on that line. Now the red line was a little trickier. There's only actually 2 points that work for this line. One is right there. Now none of these go through a intersection perfectly, so I'm gonna have to use the one way up here. Now looking at it, you know it's going down to the right, so it's gotta be a negative slope, so you can go ahead and throw a negative in there. And we go down 1, 2, 3, 4, 5. So we go down 5, which is a negative 5. We go over just 1, so negative 5 over 1. That slope is just going to be negative 5. If you got those correct, good job. Now, going over 0 slope. Think about if you're sledding and you're going sledding or skiing on a straight line across, how fun will that be? If you get pushed right here, if I push Teddy, he's only going to go that far. And no matter how hard I push him, he's never really going to be going that far because there's no slope. So if you go sledding on a 0 or no slope, you can say that you're going to have 0 fun or no fun. Now, mathematically explained, you can still do the rise or run for this line. Now, I can choose this point and this point. Now, rise over run, we have to count how far up or down we go first. Well, from this point to this point, do we go any up or down? No. So what number represents nothing? A 0. Rise over run, how far do you go across? 1, 2, 3. Now, if you type this in a calculator as a fraction 0 over 3, or use a division sign for the fraction bar, 0 divided by 3, the calculator will tell you that that answer is 0. And if you type that in, you get an answer of 0. That means it's a 0 slope. Now, like I said, these little arrows at the end mean this goes on forever. So no matter whether I choose this point or point way off the grid, whether it's 0 over 100, 0 divided by 100 or 0 over 100 is still going to be 0. This works the same going this way. If you type in 0 over a negative number, you will then still get 0 as your slope. Now, different story. Dealing with an undefined slope. If I find Teddy, if Teddy goes sledding on an undefined slope, what's going to happen if I push him off this slope? Well, let's see. Teddy's not going to have that good of a time. In fact, Teddy will most likely... Now, it's kind of a morbid way to think about it, but if you think undefined, if you go sledding on it, that's what's probably going to happen. So think about Teddy going sledding and never coming back on an undefined slope. Now, mathematically, let's pick 2 points. I have a point right here and a point right there. And technically you can use any of these because all those landed on a perfect intersection. Now, rise over run. We do in fact go up 2. So my rise is positive 2. Or if you want to go down 2, you can say down 2 over. But our run, do we go any left or right from this point to this point? No. So whether you go up 2 or down 2, the run's going to be 0. Now if you type this into a calculator, whether it's 2 over 0 or 2 divided by 0, your calculator is going to say this, error, as well as this one over here. So whenever it says error, that's where we get our undefined slope from. Because what you've learned in the past is that you cannot divide by a 0. So you can't divide by 0, or 0 cannot be in the denominator. So, last slide. You have 4 lines to try on your own. If you get them right the first time, you don't have to listen to the last couple minutes of this when I go over it. But go ahead, take the time now to pause this video and try these lines on your own. Alright, so for line A, we should have gotten a slope of 1/3. For line B, going straight across, that's going to be a 0 or a no slope. Looking at our C, straight up and down, we call that an undefined slope. And last but not least, line D, we know it's going down to the right, so it's got to be a -2. That means it goes down 2 over 1. Now, if you got all those right, you can go ahead and stop the video right now. If you didn't, use this time to pay attention real quick. Looking at our green line, I see a point right there and a point right there. I go up 1 over 1, 2, 3, and that's how I get 1 over 3. B, there's a point, there's a point. Don't go any up or down, so 0 over 2. You divide 0 divided by 2, you get a 0. C, a line straight up and down, you know that that is undefined. Last but not least, D, there's a point, and there's a point. There's a point. No matter which one you use, I go down 1, 2 over 1, down 2 over 1. And down 2 over 1 reduces to -2.